The last part of this section asks us to graph rational functions without using a graphing calculator, and to do that by looking at the features of the graph. So we're going to look at the x and y intercepts. We're going to look at any asymptotes it has, and then we're going to use those features to sketch the graph. So let's start with the x and y intercept. So for number 41, the function is x squared plus x minus 2 over x squared minus 9. So to find the y-intercept, we substitute in 0 for x, and when we do that, we get negative 2 over negative 9, which gives us 2 over 9. Now the next thing I'm going to do is I'm going to factor this since they are quadratics, and to make sure this will help me find the x-intercepts and help me eliminate any factors that will not be vertical asymptotes in the denominator. So the numerator factors into x plus 2 times x minus 1, and the denominator factors into x plus 3 times x minus 3. Okay, so now to find the x-intercepts, what I do is set the numerator equal to 0, and only the numerator, because the denominator, if we set that equal to 0, is undefined. So my two x-intercepts are x equals negative 2 and x equals 1. So let's go ahead and put those on the graph. So I have a x-intercept at negative 2. Whoops. See if I can get that point on there. So negative 2. And another one at 1. And then I have a y-intercept at 2/9, which I am going to count by 3's on my y scale here. So that's going to be a 1 right there. So that'll be 1. So 2/9 would be like right there. Okay. So now let's find our asymptotes. Let's start with the vertical. So we're going to have 2 since no factors canceled out in the denominator. The 2 zeros at the denominator are x equals negative 3 and x equals 3. So let's go ahead and put those on the graph. Draw our vertical dotted lines here. And so at negative 3 and at 3. And now what we're going to do is find the horizontal, and then we'll draw that on a graph. And the horizontal comes from the degrees of the numerator and the denominator. And what we have in this problem is we have two quadratics. Since they have the same degree, it's the ratio of their leading coefficients. Their leading coefficients are both 1, so it's going to be 1. So I have a horizontal asymptote at y equals 1. So that's going to be right along there. So now we have to fit the graph in these sections. We're going to have to fit the graph. If you notice, there's a division here. There's a division in here. And there's a division here based on the vertical asymptotes. But we also have it divided according to the horizontal as well. So we have to decide if we are above or below that horizontal asymptote for each section. So let's go ahead and make a table of values that are near the features of the graph. So when I do that, let me just write that down here. So this table is near the features. And by features, I mean the intercepts and the asymptotes. So make a little table of values. So what I want to do is look left and right of each of those. So to begin with, as we move from the left, the first thing we see is that we have a vertical asymptote at negative 3. So I'm going to look to the left of that. So I'm going to look at negative 4. And then I have a 0 at -2. So I want to look on the other side of that, which would be at -1. Then we have our y-intercept at 0. And I want to look on the other side of our next x-intercept. So we have a intercept at 1. So then I go to 2 on the other side of that. And then I want to look on the other side of the vertical asymptote, which is 3. So I look at 4. So I have a point on either side of all of the features that pass over the x-axis. So when I substitute those values in the calculator, I get 1.4, I get 0.25, I get -0.8, and then I get 2.6. Okay, so now I can place the graph. So if I'm at -4, I'm at 1.4, which is above the horizontal asymptote. So I'm going to be above there, like right along here, and then I'm going to be heading towards positive infinity. It's the only way I can go because that asymptote acts as a wall. Now when I look at -1, what I see is that I'm at a positive value here. And I'm at 0 at -2. And then it tells me that I really need another value. I really should look at something in between -3 and -2. And I did do that, and I saw that I had a very large negative number. And so this comes up like this, goes through the y-intercept. It's going to have to go through that x-intercept. And then if you notice, at 2, it's at -8, so it has to come back down like that. And then finally at 4, I'm above the horizontal asymptote, so that means this function had to come down and go over like that. I know this seems a little confusing at first, but as you get better at this, it becomes pretty easy at seeing the grid that happens from all the asymptotes. Okay, our last order of business in this problem is to write each of our asymptotes using limit notation. So I have to do the limit as x approaches -3 from the left. And we can see from the graph coming from the left, we go to positive infinity. Then the limit as x approaches -3 from the right. And we look from the right, we see that it's headed towards negative infinity. Then we have the one on the other side, the limit as x approaches +3 from the left. If you see, we're headed back down to negative infinity. And the limit as x approaches +3 from the right-hand side is positive infinity. And then finally, our last limit is going to be our end behavior or horizontal asymptote. So the limit as x approaches positive or negative infinity is going to be our horizontal asymptote, which is 1.